Lesson 4 in precalc trig is solving for angles. So in the previous lessons, we've looked at locating angles in the 4 quadrants. We've looked at finding the exact values or the trig ratios in these 4 quadrants, and we recognized the importance of a reference angle and a reference triangle. If we can solve the reference triangles, we solve for the actual angle. We just have to be careful with the signs. So that was this idea of all students take calculus. Today, as I said, we're going to determine angles. And the nice thing about determining angles is we're going to have to push a button on our calculator. But it's going to be important to realize that our calculator may not give us the answer we want. It may give us the answer to the reference angle, and we have to understand what we're being asked. So here's a quick example of what I mean with a point, an angle in quadrant 1 and an angle in quadrant 2. So I want you to imagine we have some point PQ. And again, it doesn't matter what the values are. And if we made a terminal arm, and again, this would be our theta and our reference angle. If we made an acute triangle, then what we would have is this would be whatever the x coordinate would be. This would be the y coordinate, and again, the radius is always positive. So if we're going to figure out the sine of p comma q, whatever those values are, it would simply plug in the side opposite compared to the hypotenuse. The cosine would be the side adjacent to the hypotenuse, and the tangent would be whatever these values are. So here's this idea of, locating an angle on the Cartesian grid, determining our reference angle, and drawing our reference triangle. If we're going to locate the values PQ in the second quadrant, so invariably we're reflecting like we did in the very first lesson, well, it'd be really important to realize the x coordinate would be negative p comma q. But in looking at these values, that's what we would have. So again, the importance of the value of the adjacent side, and again, it could be positive or negative in these quadrants. Now, in the first quadrant, up here, in our first quadrant, all ratios are positive because all those values are positive. But in our second quadrant, what we have to realize is all students take calculus S. So in this quadrant, it's only going to be the sine ratio that's positive. And if we go ahead and take that, well, the sine ratio is the side opposite our angle. And in this case, it's a reference angle. And we're going to have positive Q over the radius. But the cosine ratio is going to be the adjacent side over the radius, and the adjacent side is a negative coordinate this time, and the tangent is going to be positive over negative. So again, all students take calculus that we talked about last day. That's going to be important for us to use today. Now, in going ahead and doing what we're going to do today, again, it's very important that you draw a picture. You locate the triangle and you locate the reference angle, and then you have the reference triangle. So in order to solve for the angle, again, we're going to use something called inverse trigonometry, and that's really again, it's in your textbook, but on page 94, but it's really a button on our calculator. So if you look at any decent calculator, what you're going to see is sine, cosine, tangent, but above those buttons you have sin -1, cos -1, and tan -1, and these are the buttons you push to find an angle, and you push these buttons in grade 10. So we already know that the sine ratio of 30 degrees is 0.5. Let me just show you how to go the other direction. In order to find the angle whose sine ratio is 0.5, well, we know the answer is 30 degrees. What we're going to do is we're going to push the inverse button. We're going to enter the ratio, and my calculator is going to spit out the angle. Now, when you have the angle, you input the angle, and the calculator spits out the ratio. So we're basically doing it in the reverse direction. And this is the easiest thing to do because you are literally pushing a button. But again, what we need to realize in grade 11 is there's more than one answer to the question, and we have to understand that. So we're going to do a couple of examples just to locate these angles, and then we're going to use information from our first tutorial in order to figure out the other angle. So here's what we have. Again, we're just going to draw an angle. It really doesn't matter. So here's what we have. We want to figure out the angle whose cosine ratio is 0.8829 to the nearest. So what I want you to recognize is in this ratio, the cosine ratio is positive. And where is the cosine ratio positive? Well, again, obviously all of them are positive there. S says the sine ratio is positive, T says the tangent ratio is positive, and C says the cosine ratio is positive. So what we can go ahead, and again, I'm just going to draw a general picture. What we can do is we can put in these angles that we have to find and use our calculator to go ahead and find the angle. Now, our calculator is only going to tell us one answer. It would be really confusing if our calculator spit out all of the answers. So in this one right here, what we're going to do is we're simply going to, if we have the cosine ratio, we're going to do the inverse cosine ratio, and we're going to plug 0.8829, and our calculator is going to spit out an answer, and this is the one it's going to spit out. We're going to have to do something to figure out this one. So our calculator is always going to tell us the answer in the first quadrant, and then we have to use that information to determine, well, what the actual angle in standard positioning is. So given that all of them are positive, in this case, one of them is going to be in the first quadrant, and in this case, the second one's going to be in the fourth quadrant. So we get out our calculator, and we go inverse cosine 0.8829. So we're going to, in grade 12, you're going to learn why you push this button, but for right now, we're just going to say this is how we use our calculator, and we're going to get 28.00. So normally what I do is I want answers to angles in integral values, nice, no decimals. If you're going to use it in an intermediate calculation, then you always take it to 4 decimals, but final answer, we want a nice one. So here's what we know. We know that the cosine ratio in the first quadrant is 28 degrees. That's great. That's one of the answers I want. But in quadrant 4, as we saw the other day, we figure out theta by subtracting. So theta is equal to 360 minus theta r, which is equal to 332. Now our calculator doesn't tell us that, but we can use our calculator to check our answer. So when we take the cosine of 332 degrees, we need to get 0.8829. And there you go. There it is right there. So again, we're putting things together here. We're building. And we have to know lots of things. Okay. So in our second one then, we want to know the angle that has a tangent ratio of that. And again, we have this idea of all the ratios students take calculus. So In the first quadrant and the third quadrant, the tangent ratio will be positive. Well, we don't want a positive ratio, so that means the tangent ratio will be positive in the second and the fourth, or it will be negative, sorry, in the second and the third quadrant. So I'm just going to draw this basic picture right here. It doesn't have to be perfect, but when we push our button on our calculator is going to tell us the answer to this one right here. So what we want to do is we want to disregard this negative. That negative gives us this information. It tells us the answers here and here. If we disregard the negative, our calculator is going to tell us this angle, and then we're going to use that information to figure out these two angles. So we're going to treat the answer as a reference angle, and we're going to use that in order to go ahead and solve the problem. Okay, so here's what we have then. We have the tangent of the inverse tangent of 1.9626. So I want to know whose angle has an inverse, has a ratio of 1.9626, and we go second, tan 1.9626, and we get 63 degrees. So all we have to understand is, what is that 63 degrees telling us? And this is what it's telling us right here. It's telling us in the first quadrant, 63 degrees has that. But we also know that the value of the tangent is positive right there. So what we want to do is we want to use that information to understand that this is also 63 degrees and this is also 63 degrees. So in order to figure out our theta in the second quadrant, I'll just locate it like that. Well, that's equal to 180 minus our reference angle. That's 117 degrees. And we'll go and make sure that this is right. That's a great thing about our calculator. We can check. But in theta 4, our angle, here's our theta over here, is equal to 360 minus 63, which is 297 degrees. So remember, negative 1.9626, let's go ahead and go, oh, what's the tangent of 117? There you go. What's the tangent of 297? There we go. So look what we did on both of these examples. We used our reference angle and our reference triangle to locate angles, and we also used this acronym, All Students Take Calc, in order to locate which quadrant the angles might occur. So let's look at a few more examples. Again, one of the ones, an example that was similar to something we did before. Point -5, -4, -5 is the terminal arm on angle theta and standard positioning. Determine this angle. So again, it's always a good idea to draw a picture, even if you don't need it. So -4 there, -5 there. Here's my coordinate, -4, comma, -5. And again, we're going to construct our reference triangle, and here's our reference angle. And when we locate our numbers, here's our -5 and here's our -4, and in determining which trig identity we would use, well, I have the opposite to the reference and I have the adjacent, so that points out my tangent. So the tangent of our angle is equal to -5 over -4, or the tangent of this angle is equal to 5 over 4. Our calculator doesn't care. And in order to find the angle, we're going to press the inverse trig button with our ratio. And remember what this is going to do. It's going to spit out this value up here. So in this one, let's go ahead and do it. And we're going to have the second tangent, that's the one to find an angle, 5 divided by 4, and always get in the habit of closing. And here's what we get, 51.3. So our angle is 51.3, but obviously that would be in the first quadrant. But remember what that represents. This represents theta, but it represents this theta, which is our reference one. In order to figure out the actual theta that we want, well, we have to add 180 plus the 51.3. And when you do that, you get 231.3, and we'll just round it to a nice answer, 231. So again, it's this notion of if you draw the picture, you will see the angle you're finding, and again, that's going to be a reference angle, and then you're going to use your picture to actually figure out the angle in standard position. Exactly what we did the first day, but we're building on it. Okay, solve the cosine of an angle is equal to -1 over root 2, 0 to 360. So whenever you see a ratio that looks like this, hopefully you're thinking exact values, but it doesn't matter right now because we're using our calculator. So here's what we have. We want to solve this one. I want to know when the cosine ratio is negative. So again, where is the cosine ratio negative? Well, they're all positive here, so it's not there, and the cosine is positive there, so it's not there. So here's where those two triangles are. And again, I'm just going to quickly sketch those two triangles. It doesn't have to be perfect. And here's our theta right there, and here's our theta right here. And the cosine ratio is the adjacent to the hypotenuse. So here's the adjacent for both those triangles, and here's the hypotenuse right there and right there. So what we're going to use is, we're going to use this information to help us with this theta, and then I'm not going to draw it right now, but to go all around to the second radii. So again, in order to find this angle right here, we're going to use the inverse button. And again, our calculator, we're gonna, we could do it two ways. I'm gonna disregard this. I'm gonna imagine that it's just gonna tell me the answer to this. And when it does the answer to that, it's always in the first quadrant, and then we're going to use this information to help us. So when we do that, when we push that button, we get 45 degrees. So that means that the reference angle is 45, and whether you think of it in terms of this or you figure it in terms of this, it doesn't make a difference. So in quadrant number 2, theta is equal to 180 minus 45, which is 135 degrees. And in theta 3, in quadrant 3, the angle is equal to 180 plus 45, which is equal to 225. Now again, I'm disregarding the negative because the negative tells me where in the quadrant it is. I'm just doing like a grade 10 problem by disregarding the negative and by using all students take calculus. And just to check our answer, -1 over root 2 is about -0.7071. So let's see what the cosine of 135 is. And there it is right there. And let's see what the cosine of 225 is. And there it is right there. So both of those are correct. Okay, one last one. Again, these are those quadrant angles. We want to figure out the sine, where sine theta is equal to 0 for angles greater than or equal to 0, but less than 360. So 360 and 0 are the same thing. So in this one right here, again, if we got out our calculator, we could just go theta is equal to the inverse sine of 0. And again, what our calculator will tell us is it will tell us the answer in the first quadrant, like grade 10 math. So again, we could just get out our calculator, second theta, 0, and our calculator is going to say 0. Now remember what that represents. That represents 0 degrees. So here's what our picture would look like. It would look like that. Remember, this is 1 comma 0. Now, what's going to happen is if we remember that applet that I showed you yesterday, in order to help you understand these quadrant angles, 90 degrees, 180 degrees, then what happens is you have to understand what the x value and the y value do. So if we just went up a little bit, if we imagined our reference angle changing a little bit, then what's going to happen is the first number is going to represent our adjacent, because it's the x value, right? It's this one right here. This is the adjacent side. And this number right here is going to represent the vertical, the y, which would be the opposite. So here's why 0 is an answer. When we look at the sign of 0, well, that's the opposite side, which we imagine the vertical to be 0, over the radius, which would be 1, just like we looked at the other day. So in this picture right here, the sign of 0 is 0. But if we go all the way over to this side over here, again, I'm just going to draw that little picture like our applet, the sine ratio would be the opposite over the hypotenuse. And what's happening is the opposite is getting smaller and smaller and smaller, and it's getting to 0. So there's also another answer. And the other answer is theta equals 180 degrees.